Hey guys, this is our recording of our simulation videos. We did parts A and B by hand, and so we started with part C with like MATLAB code. So for part C, all you to do is hit run. We formulated a controllability matrix, and what we did is we have it symbolically, but then we would go in here, right here, comment this out, comment this, comment those in, comment this out. Then we would test different values to see where the rank condition fails. So as you can see for, L1 and L2 the same, the rank is not full, therefore it's uncontrollable. So we did this simplification thing to make it a little bit easier to read. So that's part C. And then part D, we have our LQR controller. So the first thing we do, you gotta click in here, hit run section, checks the controllability for the given parameters. Next thing is we designed a first passed LQR controller with Q as an identity matrix and R is just one. So to run the simulation, you hit run section. And then it should output, come on, here we go. This is the response to initial conditions with bad Q and R values. It also outputs the eigenvalues for Lyapunov's indirect method. Now, this is our tuned values for Q and R. You can see how we made the adjustments here. And to run this simulation, you hit run section again. You can see response is much better after we tune Q and R. Same thing, you can see that our eigenvalues are printed again for Lyapunov's indirect method. Now, for our nonlinear system, we kept Q the same. We had to change R a little bit to get a better response. But if you want to see our bad R, you can comment this in, comment this out. But basically, hit run section here, and it shows you our nonlinear response. Part E, it's very similar to part C, but it's observability. So we just tested each of the output vectors individually. So to run this one, all you gotta do is hit run, see where the rank condition fails, and that's how we got C2 is not observable. Part F, it's a little bit longer, it's our observer. So the way you do this is first you run the setup, which basically just defines everything. Then you place your poles. Then you form your closed loop systems. And now each of these are the linearized system. So here's our observer. We get both step response and response to initial conditions for the first observer. Response to initial conditions, step response for the next one. And for the third one, same thing. Step response, response to initial conditions. Finally, this is our LQG controller right here. All you got to do is hit run. And then we have our state variables, how those respond under LQG control. Then we also took our smallest output vector, and this is what that looks like. And yeah, that is our simulations for this project.